Okay, so this video is going to be determinant and Cramers rule. Mind you again that we're using these matrices to solve systems. That's the purpose, is to solve systems, right? So we're going to use the determinant, which is a number, and Cramers rule, which is a method to solve. It's obsolete. There's really no reason for it now, but it's the sort of the history of mathematics a little bit. Math teachers definitely find it a little more interesting. It's a sort of like a mathematical magic that happens, but it's something that we do want to go at least introduce, and you do have to do it without a calculator, because you will know how to do it quicker by the end of this class. Alright, so determinant, it is a number, so that's the first thing you got to recognize, that it is a number. Alright, it's helped find inverses by hand. It's using Cramers rule. It gives us some geometric properties, so we can find like area or something like that. It's some higher level math and kind of thing, but you're just going to be getting an introduction. You'll see it as DET, so determinant. So the only one that you have to do by hand is a 2x2 matrix. All the other ones are much more complex, and basically we don't need to do that. Alright, so if you have a matrix that's a 2x2, you're going to take A times D minus B times C. And this is going to give you a number. So you're going to get that number. So it is a number. And if you get determinant is equal to 0, then it's infinite or no solutions. It's one of the two. Okay, so make sure you have these down in notes. Guys, remember that you get a full page for your every test, so you should have this kind of thing on your notes. Alright, here's an example. This matrix, the 2x2 matrix, we have 2, 5, 1, 3. And so 2 times 3 is 6. And 5 times 1 is 5. Subtract them, gives you 1. This is a very, very simple one for a 2x2. With 3x3 matrices, it takes a little more math. Example 2, 8 times 4 is 32. 3 times 2 is 6. So again, the first thing, just a huge thing that as we're dealing with this, I have to remember, and you have to remember, that this is the first time you've ever seen matrices properly. And so this is a lot of language that you have to recognize. And again, so determinant is something that you have to know what it's used for, okay? And then it's DET, so you can see that on your calculator. Oops. Alright, so yep, next one. So solving a system, okay? So we're going to use the determinant, and we're going to use what's called the Cramers rule. Alright, so if we have a system here, this whole thing that's here in green, this is the system, right? It's 2, 5, 26, 1, 3, 15. Notice, by the way, that the x's line up, the y's line up, and the answers line up. Okay, you got to make sure they line up. So we're going to do the determinant for this part here. So it's 6 minus 5, which is 1, very convenient. Now, Cramers rule says that it makes it so you can find just one solution. This D here represents the determinant of the original problem. In this determinant with an X, that is when the X column is replaced with your solutions. So that means that you would replace this 2 and this 1 with a 26 and a 15, and then find that determinant. So if I do that, so the 26 and 15 have replaced this column. Okay, so now that my x has been changed, and if I do the determinant, I get 3. So the rule states that the determinant of x divided by the original determinant will yield the x solution. Hey, look at that. What a quinky-dink. Doesn't always work out that way, but determinants cancel out. And so that's going to give us that. So if I wanted to do it again and say determinant of y, and divide by the original determinant. Now the original determinant was just simply 1. Now let's replace, let's go back to, let's create the matrix here. Let me take a glance what this was. It was, again, it was 2, 5, 1, 3. So we had 2, 5, 1, 3. However, we had 26 goes here, and whoops, 15 goes here. So this determinant, which would be 30 minus 26, because that, so it's 4. So 4 divided by 1 is 4. Seems sort of neat. Again, by the end of this unit, it'll be obsolete for you, but you still have to do a couple of problems. You have to be able to do the determinant for a 2x2 by hand. Okay. Cramers rule, again, is, here's a second example. We have another system. I start off this example here. Notice how the x is not lined up with the x. Well, that's not acceptable. So we're going to take this x, it's going to go to the other side. So if it's negative over here, it becomes positive. So now we have the x's in a row, the y's, or excuse me, in a column, the y's in a column, and the numbers in the column. Okay, so now, using the coefficients here, I'm going to get 12 minus 2, which is 10. So my determinant is 10. Now I'm going to replace the y's here with the solutions, which are 17 and 21. So this is here. Now if I do the determinant, now the new determinant, that gives me 84. Oops, I already did over here. 84 minus 34, which is 50. But the original determinant was 10. So then the y is 50 divided by 10, which is 5. So the y is 5. So that's just one of those things that we can do here. You can find the determinant on your calculator, which is pretty easy to do. But this seems really silly to do with a 2x3 matrix, but we can do this also with a complex 3x4 matrix where you have like something like 1, 5, 7, 10. You know, where here's your solutions over here. So it's 1x plus 5y plus 7z equals 10. And you've got another row and another row. And well, yeah, it's this way is not very much fun to solve by hand. So calculator is definitely going to come to play. All right, I hope this is a little bit helpful. Reminder, let's go back here, that the determinant is a number. The Cramers rule is a method to solve. Right? And you need the determinant in that method. Okay? And the 2x2 is the only ones you need to do by hand. Okay? We also use the determinants to help define inverses. Okay? And just a reminder that it's the A, B, or the A, these corners minus these corners. Just again, corners minus the corners. It's a number to produce a determinant. In solving a system, if I'm going to solve for the x, I find the determinant of the original, and then I take my solutions and I replace my x's, and then find the new determinant, and look at the determinant of x divided by the determinant, which is going to produce x. If I had switched the y's, determinant of y's divided by the determinant equals the y's. Alright, and so the Cramers rule is just nice and makes it so you find just one solution. It's neat. Again, will be obsolete by the end of the unit. But you still have to do one of these by hand on the test. Alright, hope you find this helpful. Enjoy.